they ask us this guiding question of how can we use our prior knowledge of algebra to learn how to solve geometric proofs. Okay, so whenever we are solving an equation, like if you had what we were just doing, 6x plus 3 equals 12x minus 4, right? You move things from one side to the other so you can get x by itself, right? So you're going to add something or subtract something, and then maybe you have to divide as well, right? All of those would be reasons behind whatever step it is you're doing, okay? So those are all these properties that we're going to talk about here. So our first property is what we call the substitution property. And just like it sounds, it literally means to substitute something in for something else. So this property says if you have some A equal to B, and A and B could be anything, any number, any variable, then A can be substituted for B in any equation. Okay, then we have our distributive property. Okay, so the distributive property says if A times B plus C, then AB plus AC. Whenever we distribute something, that means to multiply it into a parenthesis, right? So let's say we were given A times B plus C in a parenthesis. Then all I would do is distribute that A to both factors inside, right? So I would end up having then A times B plus A times that C, right? So an example that you might see of this would be like maybe 3 times x plus 2, right? If I have 3 times x plus 2, once I distribute, what does that become? 3x plus 2. Very good. All right. Okay. Our next property is what we call the reflexive property. Okay, and this says for any number segment or angle, so this will work for our algebraic proofs as well as our geometric proofs. If you have something, maybe it's just a variable, right, just a number. A is equal to A, so it equals itself, basically. If you're talking about a segment, like some side in a shape, maybe the side is called AB. If you have AB, then it is equal to AB, even if it's part of another figure. And as far as angle goes, if you have some measure of an angle, it is equal to itself. So the reflexive property just means that if you have something in a figure, even if it's a shared side or a shared angle, it's going to be congruent in both. Okay? All right, next property is our symmetric property. Okay, our symmetric property says for any numbers, segments, or angles, if A is equal to B, then B is equal to A. Basically, our symmetric property is saying that it doesn't matter the order you write it in. It's still true, okay? If I was talking about some segments, so if some segment AB is equal to some segment CD, then I can also say that CD is equal to AB. AB. Okay. And same would be true about any angles that we're dealing with. If the measure of angle A is equal to the measure of angle B, then I can say that the other way around as well. The measure of angle B is equal to the measure of angle A. Okay. Then we have our transitive property. Okay. So transitive property is similar to that substitution property in that it's still going to be for any of our number segments or angles. But basically, if you know something equals something else, and it's also equal to something, you could say those two things are equal to each other. So the way we would write this here is for any numbers, segments, or angles, if A is equal to B, and you know that B is equal to C, then I should be able to say that means A and C are equal to each other. Okay, and this is also true for your sides or your angles as well. So if you were looking at some side lengths, if you had AB is equal to CD, and you know that CD is equal to EF, then I should know that AB and EF are equal to each other as well. So this is one that we'll use a lot in our proofs for our angle pairs. Okay. And same is true for angles, but you don't have to write that. All right, and then these are pretty specific to our algebraic proofs. Like we were saying, whenever you're solving an equation, you add something to one side or subtract something to one side. That would be these properties here. Okay, so the first is our addition property. Okay, and this property says if you know that A is equal to B, then if you add C to A, it should still be equal to B as long as I add C to it as well. Basically what this says is you can add the same number to each side of your equation. Alright. Okay, the subtraction property is very similar. If you know that A is equal to B, then you should be able to subtract some value from each of those and it still be equal. So here you can subtract the same number from each side. And then our last two properties are our multiplication and division properties. So our multiplication property says if you know that A is equal to B, then I should be able to multiply both of those by the same number and them still be equal. So then I should be able to say A times C would equal B times C. You can multiply each side by the same number. Alright, and then last one is our division property. And this one says, if you know that A is equal to B, then you should be able to divide those terms by the same thing and them still be equal. So A divided by C should be equal to B divided by C. Now this one is only true as long as C is not 0, right? Because we're not able to divide something by 0 or have 0 in the denominator of a fraction because it doesn't exist, right? Okay, so this one just says you can divide each side by the same number. Okay, so once you have all of these properties written down, if you'll flip it over onto the back, we are going to do a couple of proofs using these properties as our reasons or our justifications for what we're doing. Okay, so typically whenever you are writing a proof, later on if you take higher level math courses in college that require proofs, your proofs end up being like written as paragraphs. Okay, but what we're going to do in this class is what we call table proofs. Okay, so it saves us a little bit of writing. Whenever you start proofs in a intro to proof class in college, they're going to talk a little bit about truth tables, and it's kind of set up the same way. But what you do is we're going to make any statement that we want to make in the first column, and then we back that statement up with a reason in the second column right beside it. Okay? So, they give us this problem 2 times x plus 1/2 equals 0. Okay? So, whatever they write down here is called your given. Alright? And if we're supposed to be solving for x, then we're trying to prove whatever it is that x equals, right? So we are given something, our end result is to prove something specific. In this case, we're trying to prove x equals something specific. Alright, so whenever you do a proof, the first thing that you always write down as your statement, the first statement is always your given, so you know your starting point. So for us, the first thing I was told was that 2 times x plus 1/2 is equal to 0. Okay, and that's not any property that tells me that specific fact, right? That was specifically given to us in this problem. So, your first reason is given. It was given to me. Okay, so that's how all of our proofs should always start. They told me something, the reason is it was given, all right? And then from there, we start to solve or prove whatever it is that we're looking for as our end result, which for us is to get x by itself. Okay, so what would be the first thing we would want to do here? Yes. Right, we're going to distribute. Okay, so if I distribute the 2 into that parenthesis, then I'm going to have 2 times the x plus 2 times the 1/2 equals 0, right? Okay. And my reason for that was, what did we say we did? We distributed. So my reason would be the distributive property. Okay. Now, there are 2 ways you can go about it. Sometimes they want every single justification behind everything, okay? And that's what we're going to do here on this first one. So this is when we're being very picky, all right? So, we know that what 2 times x is, and we know what 2 times 1/2 is. But when I write that on the next step, which I could have just written here, right? I'm going to write down that this would be 2x plus 1 equals 0. And what I did to turn it from this into this is just simplify what was already written there, right? So I had to add in this extra step of simplification. So all I did here was simplify. Okay. All right, so then what would we want to do next if we're trying to get x by itself? Subtract the 1, okay? All right, so then my next step would be to subtract 1 from both sides. So the way that would look is x plus 1 minus 1 is equal to 0 minus 1, right? To show I'm actually subtracting from each side. Like you guys said, all we did here was subtract, so my reason, or the way I back that up, is to say we use the subtraction property. Okay, now before we move on to the next step, what am I going to need to do now? Simplify. So my next step would be 2x is equal to negative 1, and all we did here was simplify. Alright. Okay, what would we want to do now? Divide. Very good. So I would say that 2x divided by 2 is equal to negative 1 divided by 2. And what am I going to list as my reason? Right. Okay, and then what would be the last thing we'd need to do now? Just simplify. Good. So I would end up with x is equal to negative 1/2 or negative 0.5, right? And my last step would be that all we did here was simplify. Okay. Now, as far as the proofs that we do in here, I'm going to let you leave out that extra step of simplify on every single one, okay? So this would be if we were just going to do it the normal way without that extra simplification step, okay? So we ended up proving this piece right here, right? So we were given, So we were given this information, and we proved that x was equal to negative 1/2. What is my given on example number 2?
12x minus 3 times x plus 7 is equal to 8x.
Perfect. So right here is my given. And remember, that's what we always write down first. Okay, so my step 1 is 12x minus 3 times x plus 7 equals 8x. And what is my reason for it? Given. Okay, so now we're going to start to solve. What do you guys think we should do first? Distribute, okay? Now this time, instead of just writing what it means to distribute, we're going to go ahead and distribute all in the same step, okay? So I'll have negative 3 times x, which is just good, and negative 3 times 7, which would be, right. Okay, and all we did here was use what property? Right. Okay, so we kind of combined two steps that we would have had separately before there. Okay, what should I do now? Simplify, right? We're going to combine some like terms. So whenever I simplify, what am I going to have? Very good. All right, and my reasoning behind that, like you guys said, all we did here was simplify. Okay. What should we do now? Subtract, right? Okay. So whenever we subtract, yes, you could move the 8x over here, but then that means you have to move the 21 to the other side. And when you're doing a proof, you want to get there as quick as possible, right? So the quickest way to do this would be to move the 9x over to where the 8x is. So if I subtract 9x from both sides, I'm going to end up with negative 21 is equal to negative x, right? And my reasoning behind this would just be that we subtracted, so subtraction property. Alright, and then what should we do? Divide, right. So if I divide, I'm going to end up with 21 is equal to x. So all we did here was divide, so division property. Okay. You also could multiply by -1, right? And that would do the same thing. And if you chose to multiply, you just put multiplication property here. All right. Now, typically, whenever we write that a variable equals a number, we list the variable first, right? And then the number second. So if I want to do that, then I would rewrite it in the other direction. And which property was it from the front that said that it doesn't matter the direction you write it in? Symmetric, right? So my reasoning behind that would be symmetric property.